Hey guys, welcome back to the laboratory. In this video, we are looking at the solubility of different salts. By the end of this video, you should be able to recall soluble and insoluble salts, identify whether the reaction between two soluble salts will form a precipitate, and explain the method for preparing insoluble salts. So, let's go. The solubility of a substance is a measure of its ability to dissolve. A substance that is very soluble is described as having a high solubility, meaning it dissolves easily when added to a solvent, whereas a substance that isn't very soluble is described as having a low solubility, and therefore doesn't dissolve as easily when added to a solvent. We can summarize the solubility of ionic compounds using the table below. All ionic compounds containing a nitrate ion are soluble. Almost all ionic compounds containing a chloride ion are soluble too, with the exception of silver chloride and lead chloride. Ionic compounds containing a sulfate ion are soluble, excluding lead, barium, and calcium sulfate. Most common carbonates are insoluble, with the exception of sodium, potassium, and ammonium carbonate. And most hydroxides are insoluble too, excluding sodium, potassium, and ammonium hydroxide. We can use the rules from this table to identify whether a precipitate will form in a reaction between two soluble salt solutions. A precipitation reaction is a reaction whereby an insoluble solid, or precipitate, is formed as a result of a chemical reaction. These reactions can occur when two soluble salt solutions react with one another. For example, potassium carbonate and copper sulfate are both soluble salts. When the two react, the carbonate and sulfate ions are swapped. The products of the reaction are potassium sulfate and copper carbonate. Using the general rules from the solubility table, we know that potassium sulfate is a soluble salt, and so will not form a precipitate. However, copper carbonate is an insoluble salt, and will therefore form a precipitate in this reaction. This is better demonstrated in the symbol equation for this reaction. Here, we can see that the potassium sulfate is followed by the state symbol AQ, indicating to us that it has dissolved in solution and is therefore soluble. However, the copper carbonate is followed by the state symbol S, indicating to us that it's in solid form and thus has formed a precipitate. Here's an example of a quick task that you can attempt to test your understanding of precipitation reactions between soluble salts. Pause the video and take your time to work it through. Press play once you're ready to check your answers. Let's talk through the answer to question 1. When sodium chloride and ammonium nitrate react with one another, the chloride and nitrate ions are swapped. The products of this reaction are therefore ammonium chloride and sodium nitrate, both of which are soluble salts. There will be no precipitate formed in this reaction. Here are the answers to the remaining questions. The lead sulfate formed in the second reaction and the calcium hydroxide formed in the third are both insoluble and will therefore form precipitates. So, how did you do on this task? Let me know in the comment section below. A pure dry sample of an insoluble salt can be prepared via the precipitation reaction between two soluble salt solutions. For example, copper carbonate can be formed via the precipitation reaction between potassium carbonate and copper sulfate. To begin with, the two salt solutions are mixed together in a beaker to form potassium sulfate and copper carbonate. As the insoluble copper carbonate forms, it will settle at the bottom of the beaker. The mixture is then separated using filtration. The mixture is poured through a filter funnel that has been lined with filter paper. The solid copper carbonate is trapped in the filter paper. We call this the residue. The potassium sulfate solution passes through the tiny holes in the filter paper and collects in the conical flask. We call this the filtrate. Next, the copper carbonate is rinsed with distilled water whilst it sits in the filter funnel. As the copper carbonate is insoluble, rinsing with distilled water will remove any excess contaminating solution, ensuring that the sample obtained at the end of the process is pure. Finally, the precipitate is placed into a warm oven to allow any excess water to evaporate. Before we finish up, Here's an example of a past paper question that you can attempt to test your understanding of the concepts covered in this video. Pause the video and take your time to work it through. Press play once you're ready to check your answers. There are 3 marks awarded for this particular question, meaning there are 3 key points your answer must include to achieve the full marks. The question specifically asks for a pure, dry sample of barium sulfate, so it's important that your answer covers these areas to achieve the full marks here. To begin with, we must separate the barium sulfate from the potassium nitrate solution, and this can be achieved using filtration. Next, we must rinse the barium sulfate using distilled water. This step removes any excess potassium nitrate solution, ensuring that the sample of barium sulfate is pure. Finally, the barium sulfate is dried by heating it in an oven. So, how did you do on this task? Let me know in the comment section below. Anyway, that's it for this video, guys. Thank you for joining me in the laboratory. Please leave a like on this video if you found it useful, and don't forget to subscribe to the channel so that you don't miss another one. See you soon.